Okay, good day. We're going to continue in Chapter 8, Section 5, talking about the chi-squared test for variance or for standard deviation. And this time we're going to begin with example 8-24. So here the important formula is how we compute the test statistic. And here it is going to be the chi-squared test. We're using the chi-squared distribution. And so the test statistic that we calculate is going to be a chi-squared value. And the way we do this is going to be by n minus 1 times s squared, all divided by sigma squared. So we're going to do an example in just a second, but let's just go ahead and go through the various different possibilities for what our alternative hypothesis might be. So, almost wrote mu there. We're testing sigma or sigma squared, and so in our alternative hypothesis, if we want to just say there is a difference between our variance and whatever the hypothesized value was, we'll just do it like this. I'll say sigma squared not equal to whatever, all right? And that would be a two-tailed test. Okay, if sigma squared is less than whatever the hypothesized value of sigma squared is supposed to be, then it is going to be left-tailed. And then finally, if it is stated as we think it's greater than a certain value, whatever it may be, then it is going to be a right-tailed test. And let's go into the example that I've been saying we're going to do. So that is example 8-24. We're looking here on page 464. And in this problem, it says, a psychologist wishes to see if the variance in IQ of 10 of her counseling patients is less than the variance of the population, which is 225. Okay, so we're talking about variance, that is sigma squared, and the hypothesized value is 225. Okay, the variance of her 10 patients, so there we have n is equal to 10, was 206. And so here, remember, her 10 patients are the sample. So there we're talking about s squared. All right, and then finally, we're going to test the claim at our standard alpha equals 0.05 value. Okay, so that is what we have. And now let's go through the 5 steps in the traditional hypothesis testing method. We'll start by saying h subscript 0, the variance sigma squared is equal to 225. And for our alternative hypothesis, we're going to just simply say, oh, I'm sorry, she thinks it is less. Wishes to see if the variance is less. Okay, so it is going to be a left-tailed test. And notice this. I'm going to comment on this. A lot of the time I see people mention information about the sample when they're talking about the alternative hypothesis. Keep in mind that this value that we're talking about in h subscript 0 is going to be the same as the one that we have in h subscript 1. We're simply saying a statement of equality in our null hypothesis, and we're saying an inequality, but using that same value in the alternative hypothesis. All right, step 2, we're going to go ahead and find our critical region. So we'll go ahead and sketch our distribution curve. It's a chi-squared distribution, so we have to include degrees of freedom. It's going to be 9 degrees of freedom. And it's a chi-squared curve, so that's why I've drawn it so it's skewed to the right there. And then to just signify what this is, it's a left-tailed test. And so here our chi value is going to be 1 minus alpha. All right. So this is 0.05. That's the area that we want. The reason that we're doing 1 minus 0.05 is because that's the area to the right. And the chi-squared distribution only gives us areas to the right. And the value that we find in the table, so again, we're in row 9, corresponding to 9 degrees of freedom. We're going to just simply go over to the 0.95 column. Okay. Notice that as you go along the row in table G, the values keep increasing. So keep that in mind. Make sure if you're doing a left-tailed test, you get a value that is small. Okay, these aren't going to be negative, but this value on the left is going to be closer to 0. If you get something that's not very close to 0, maybe rethink that and double check it. All right, so we have our critical region. Now, step 3, we'll compute the test statistic. So the way we do that is it's a chi-squared value. It's going to be n minus 1 times s squared, all divided by sigma squared. And we substitute n in place of n, we're using 10, so n minus 1 becomes 9. S squared is 206, so 9 times 206, all divided by 225. And that works out as 8.24. So then we're going to make the decision. We flip back the page. Notice here, change it to red, we have 8.24 is higher than 3.32. 3.325 was this value right there. And so notice that we are outside of the critical region. Sorry about the audio, garbled a little bit. And so we do not reject H subscript 0. Okay. And so that means what? We didn't reject the null hypothesis. So we just say, well, the evidence didn't appear. The evidence that supports our claim didn't appear. We didn't prove the claim. We didn't prove that the null hypothesis is absolutely true. We just didn't reject it. And we summarize that. We conclude by saying there's not enough evidence to say that the variance is significantly less than 225.